It is my honor to introduce my previous boss, my good friend, Brian Carrier. Brian is always fantastic speaking at these things. He is the mastermind behind SleuthKit, Autopsy, all the great things, the File System Forensic Analysis Bible that if you don't have, you should purchase. So Brian, thanks for all that you do for the community over all these years. We know you're like 25 years old, a fresh young soul out there. You're Doogie Howser, right?
Exactly. Now I have the gray hair though. Now it's like the,
You look distinguished. It's good looks good.
Thank you. Well, thank you very much. And thank you, Sans, for putting this on. I know these are always a lot of work. We did a virtual OSDF con last year, and this year we're doing a hybrid, and we realized it's actually twice as much work to do a hybrid in-person and virtual event. So I wish you all the best as well for planning for next year, because it's a lot of work, but these are all great events to get a wide exposure to people. So today we are talking about scoring and judging artifacts in Autopsy. Let me see if I can change the screen. I'm clicking. There we go. All right, there's my slide. All right, so the general problem that we're talking about here today is data overload. Right. This is not new, right? But everyone knows, right? Cases are getting bigger and bigger because they have more and more devices. Devices are getting bigger and bigger. This has been a theme for years, right? For 10, 15 years, this has been a problem of kind of more and more devices and bigger and bigger. And we need constantly evolving solutions to deal with this. And so, a bunch of talks yesterday that I saw were variations on this theme on like, hey, how do you pick out the artifacts that are interesting or not? What we're talking about today is one part of the solution to kind of help incorporate all of the great things that like Chad talked about yesterday with Cobalt Strike on, bringing those things in to find out and help you all find these things faster in that process. So we aren't alone, right? This is not a unique DFIR problem of kind of data overload, information overload. There's a field called information retrieval that since the 70s has been working on various ways of like ranking data in your search results to put the most relevant ones on top. And of course, Google PageRank is the most famous one of these that really accelerated them over things like Alta Vista that most of you probably never heard of, right? That kind of really focus the most relevant things, on top. So we need these concepts in DFIR, right, to get through all of the thousands and millions of artifacts that come in to kind of focus on the ones that are relevant. Now, to be clear, PageRank is useless, for forensics, but we need these kinds of ideas on trying to figure out kind of what is relevant and not relevant. So in Cyber Triage, we've been doing this for a while, right? So in Cyber Triage, which is one of our tools, I have a slide in a little bit later on just to kind of get some context. There's scoring, right? So when all the thousands of artifacts come in, you're given a little dashboard with kind of, hey, there's 5, high threat things and 14 suspicious things, and you can start off in those 19 places and start looking at them. So how do we do that? Right, so Cyber Triage has been doing it where there's a bunch of modules that are running in the background, analyzing the artifacts that come in, and they assign scores to them. And the users then kind of can focus on the highest scores first. So as an example, right, there's a malware analysis module that uses reversing labs, and it goes out to 40 plus malware scanning engines. And if 25 engines come back and say, hey, this is malicious, it gets a score bad, right? And then you'll see it in the UI as bad. Another file may go through, or a startup program may go through or something, and our path module may flag it saying, hey, this is kind of weird. It's executable in app data, right? This could be malware. It could be Google update. Who knows? But this module's main job is to flag things based off of where they are. But then the malware module comes back in and says, you know what? No engines flagged it. It's been a year old. This is probably okay, right? This is not kind of some new crazy thing. It's probably just Google Update or Join Me or one of the other things that runs out of app data. And so the final score is okay, right? So even though this module thought it was a bit fishy, this one thought it was okay, and they resolve out to be, it's fine. So this has been going on for Cyber Triage a while. We've had various kind of iterations on this, but this has kind of been there for a while. And we've now moved it into Autopsy. So in the version coming out, I think Monday. We hope we get this week out, but we had some vacations didn't kind of plan for back to the last talk. And so this will be up Monday or next week with a new version. And you will now see these scoring values in the UI, and we're expanding it to basically, hey, allow you to focus on kind of certain files and artifacts first, using this kind of voting system among various modules instead of simply a tag or kind of a hard kind of scoring of that. So the goal of this talk is to introduce the general scoring concepts, and then we'll kind of talk about outlining changes that have been into autopsy. I have no clue why I have slide 1 and 1 on their bulleting, but sorry about that. That should be 2. All right, so basics, just make sure we're on the same page of what is Autopsy. Autopsy is an open source digital forensics platform. I'm not using a term that I hadn't used before, but the past couple of years started to use this term of it's a general purpose forensics tool, right? You can use it for any kind of investigation, whether it's a various law enforcement investigation or intrusion, corporate, improper behavior in corporate things, military, whatever, right? It allows you to get access to data, see data, view data, search data, but you need to know kind of where to look, but it's very general purpose, right? Our design principles have been ease of use, kind of intuitive, that you can kind of start using it pretty easily, getting your results quickly and not waiting for an entire ingest to be complete before you see things, and extensibility. There's a lot of frameworks in there. The core idea of starting in version 3 about 8 years ago is really, we're not going to solve all the world's problems. We want to make frameworks so you can have plugin modules. I think we have 80 plus plugin modules at this point. There's a slide at the end. We'll talk about how easy it is to make modules, but it's got pretty much all the core features that you need out there for forensics tools. You can download it for free. It's open source at autopsy.com. That guy in the corner, by the way, is Renzik. He is our dog mascot. Every year for OSDF Con, the dogs get dressed up in various outfits. So last year he was from The Matrix. Actually, I happen to have the coffee cup here as well from that last year. This year, Hash, his buddy, his brother, like I said, not brother, he's a bloodhound, but his relative, I don't know, whatever it is, is getting dressed up. We're trying to figure out what to dress him up as. If you have ideas, let me know. I was thinking some kind of vacationing theme, given that past talk before. But again, give us ideas. We're always looking for them. He still needs an outfit. This is a basic UI of Autopsy basic tree on the left, classic, kind of like 90s, honestly. Look here of tree, table, and some viewer on the lower right-hand side. Every year we investigate something different. This year it's forest fires. They're not good. Just to kind of complete this here, I mentioned Cyber Triage before, just to kind of get some mental model here. The differences here, Cyber Triage is our tool that is hyper-focused on intrusions. It basically is focused on just getting the artifacts associated with intrusions, startup files, WMI databases and PowerShell stuff, scores them that we're talking about today, and will recommend new ones when you tag things. It's basically brings in a lot of automation all about intrusions, but it's useless for things like, the things I mentioned before, right? Of a law enforcement investigation around child exploitation or counterterrorism or those kind of things. It's useless for it. It's all about intrusions. The reason it's tied into this talk, though, is it started its life off as an autopsy module. We separate it off in its own little world. But we're bringing it back in, and the new release of Cyber Triage coming out in a couple weeks brings back in the autopsy database. It's going to use the same core data model from a Sleuthkit and Autopsy. And the benefit here for Autopsy, which is why we're talking about this, is all this stuff that we built and researched for Cyber Triage is merging its way into Autopsy, including the scoring that we are talking about here. So it's pretty cool. So you can find more about that at cybertriage.com if you want to. So this is a screenshot of that. A little different data types, artifacts on the left-hand side, timeline on the right, whatever. Again, there's videos and stuff if you want to learn more about that as a intrusion tool. All right, so first topic here is general concepts of scoring and ranking. This section is tool agnostic. I do have this kind of academic background. I like to have kind of concept models in my mind before we actually really build stuff out to make sure we have the right conceptual framework before we build stuff. So no one else had really done this for scoring in forensic stuff. So this is more of my attempt at laying out some definitions and framework to then apply into Autopsy. But as more and more tools incorporate this kind of idea, which I think they should, these concepts should generally apply in various forms. So this is a bit kind of general for it. So topic 1, investigative question, right? This is the thing you've been tasked to answer using digital data. This is how I kind of define what a digital investigation is. Like, you're given data and a question, your job is to go answer that question with data, right? Is this computer compromised? Was this computer used to commit fraud? Does this computer contain child exploitation images, etc.? Depends on what discipline you're in, what area you're in, but you should be starting off with some question. If you aren't being given the question to answer, push back and find out you really know why someone's asking you to investigate something. All right, topic 2, relevant artifacts, right? So as part of your collection, however you collect things, you'll get hundreds, thousands, millions of artifacts and files coming in. Only a small subset is usually relevant to your investigation, right? So I'm calling these the relevant ones, right? The relevant artifacts is that small subset that you need to find to help answer your question. So if it's intrusion, you're looking for the malware, login events, kind of things, whatever, however they used to get in or what they use that box for. For fraud, maybe you're looking for spreadsheets, emails, law enforcement case, maybe you want pictures, web history, et cetera, right? It's all kind of the goals on there's some subset that's relevant for your investigation. You want to find those as fast as possible. So analysis techniques are the methods that you use to find that relevant data. Right. So these are all the things that were taught in SANS classes and various other places on how you do your investigation. Right. So you look up a file's MD5 hash in a known hash set. It could be a good set of things to ignore from a baseline. It could be bad of a bunch of bad things. That's an analysis technique that helps you figure out good versus bad. Maybe you do keyword searches on artifacts and files for relevant keywords to look at the ones that could be relevant. Or maybe static analysis executables to look for malware signatures, packing, a bunch of other kind of things on that, right? These are all analysis techniques you use to try and figure out what's relevant versus non-relevant. So the analysis result is basically what is the result of that technique on a given artifact, right? You're going to apply this technique, this keyword search, this hash lookup on all the files and artifacts, and some will be good, some will be bad, right? So the result is that this file hash was found in a known good hash set from a baseline or whatever. We can now probably ignore it, right? This email address has a phrase associated with fraud. We now want to look at this. This executable has a ransomware signature. We should look at it. And then finally, you can put a score on that, right? So once you have the result, you say, hey, this file meets the criteria I care about. We're going to put a score on it, right? Which says, what's the likelihood that that artifact is relevant to your investigative question based on your results, right? So the good hash set hit means it's not relevant, right? The keyword hit means it's maybe relevant. The ransomware signature means it's relevant. So we can then aggregate them, right? So your artifacts and files are going to have a whole bunch of analysis results on them potentially, depending on how many modules you have, what kind of things you're doing. You then kind of combine all those results to get your final score for that artifact or that file. We use the term aggregate. We were using the word final for a while. I just use it now. But there is some argument over it's not final because it may change when you add new results. So aggregate's the official term that we use for this. But for example, back to kind of the example I had with Cyber Triage, right? You made an executable. You have two analysis results. One is it's in a suspicious folder. So you give a likely relevant result. The second is, hey, it's got a malware signature. Therefore, it's relevant. And therefore, the total score is it's relevant, right? We combine the two, relevant wins. And there's the final score. So we'll discuss the autopsy algorithm a bit later on. But these are the concepts, right? Of kind of you start with questions, a bunch of artifacts. You want to find the relevant ones, use analysis techniques for that. You get some results, you put a score on them, and then those can be your starting points for your overall investigation. So that was a summary. There we go. All right. So now let's talk about what we actually did for autopsy as part of this process. So there's a new analysis type in autopsy. So called analysis results that has a score, with that. So for those who don't know a bit about autopsy kind of architecture behind the scenes, we have this concept of ingest modules, and essentially every file in the data source that you added will go down a pipeline that looks a little bit like this. It's not exactly this, but it's the basic concept that every file, as long as it passes our filters, because you can filter out things like I don't care about certain files and things, but without filters, every file goes through. It'll do things like calculate hash values, those hash values up, keyword search them, correlate them, etc. Essentially, those still exist, but now that hash lookup will make an analysis result, and we'll put a score on that with things like suspect, or suspicious, or bad, or good, or whatever. Same with keyword search, same with correlation engine. So that's new. The analysis result that gets created, and you'll see this now in the Autopsy UI as you're clicking on these things in the bottom right-hand corner, have a few fields. So one is a type. So there's a type such as hash set hit or keyword hit or whatever the analysis technique was, but usually the type is associated with what that technique was. It gives you a score, which bases how relevant that item is to the investigation itself. So likely relevant, suspicious, not relevant. Configuration is an optional setting you may find on some other results. You may not find it on certain results. An example of this is the hash set name, right? So if you have a bunch of hash sets, the set name will be put in that configuration so that you can kind of organize them and differentiate them later on, depending on where they came from. Lastly, is a conclusion, such as being, sometimes it's inferred, right? Hash set hit is kind of an inferred conclusion of it's there. Other ones aren't. So for example, in Cyber Triage, we check the signature, the code signature of executables, and there's different results there, right? Some results are unsigned, signed but untrusted, signed, trusted, signed, bad signature. There's 4, 5, 6 different conclusions that can come out of checking the signature. Those can get put in there so you can know what the result was, and different kind of scoring can be applied based on if it was, signed and trusted versus, signed and untrusted versus, bad signature, et cetera. So you can see here on the right-hand side, just graphically, we got a file hanging off as analysis result from a Yara hit. The configuration here is that it's a packed executable because it was part of a set of rules around packing, and that gives it a score of being suspicious. So it's an example. So let's talk about this score itself. So this is one of the things that evolved various times over the years as part of building this into Cyber Triage. We went from kind of complicated things to simple things to now we're kind of in the middle of kind of a medium level of complexity to make it honestly easy to use and create. So there's 2 fields in a score. One is significance and the other is priority. So the significance is all about kind of how relevant this thing is to the investigation. So we have the term notable, which means the artifact is relevant, meaning kind of you'll want to check this out pretty soon. This has got a low false positive rate. It's probably going to be bad. We have a likely notable, which means like we think it's relevant. It seems like it's going to be relevant, but we're not entirely sure. You should check it out, but maybe it's not your top priority. Maybe you should get to this, second tier as part of the process. Then we have likely none, meaning no relevance, meaning that it's probably not relevant, but it's hard to know, right? It's probably not, but it's not a baseline. It's not 100% guaranteed that it's actually good. And then we have none, meaning that the artifact is not relevant, i.e. ignore it. So you may notice that we have this kind of difference, a bunch of terms around here of relevant and notable and not. This is more of a historical context of Autopsy uses the term notable for things. We used to use bad. Then we were told that was too judgmental. So now we use notable. So relevance and notable are kind of equivalent things here. We just use the word notable in database because that's just a historical term that Autopsy has used for that. But you can replace notable and relevant, at various times. So, and then unknown means we don't have a score for that yet, right? It's unclear. We don't really know. And that's the default setting pretty much for every artifact until results come in and, start putting scores in for that. There's also a priority because sometimes you want to overrule an analysis result, right? So we have 2 priorities. One is normal, right, which is the default for all of the automated things going on in the background, all the pipeline modules that are analyzing things without human involvement and putting scores on, get a normal priority on there. And there's an override, which is reserved for manual adjustments. So as an example, you may have a Yara module that has a rule and flags something as being likely notable. But hey, it may be a false positive, right? Maybe the person made the signature and it's a bit broad and it's not really in that category of things. You don't want to see it in the UI. You don't want to be reported as being suspicious. And so you can override it and saying, you know what, it's good. It's fine. I looked into this. I know it. It's actually okay. So it just allows you to kind of have that manual overriding of things without having to remove the original score and kind of remove that history and record that notable score, was there. And then finally, the aggregate score, right? So in Autopsy, the aggregate score is stored in its own database. So every artifact can have an aggregate score, which is a reminder is kind of the combination of all of the module results that were put into that. And again, by default, everything starts off with unknown. And as more things come in, they get different scores based on those modules. So the algorithm is this that we've kind of settled on in the current version of this. So if there's any override scores that exist, then we only use them, right? So if there's any kind of manual override, then we ignore all the automations and just focus on the override. Once you have kind of your set of scores, whether they're all overrides or all kind of automated ones, then we're going to prioritize bad over good, right? If any module said this is bad, and another module says good, the fact that someone said it was bad is important, right? So we want to make sure that's not lost. So bad always overrules good. It's like as I'm saying, this is a sad kind of philosophical thing here on bad always wins. But in this case, just scoring wise, bad always kind of overrules good to what we show you to actually look at. And high confidence ones kind of overrule low confidence ones. So a notable one will, so basically the ordering is this, right? It is over here, right? These little arrows here are kind of like less than, greater than kind of mathematical symbols here of notable always wins, right? If there's any notable score, you're going to see it's notable. If it's not notable, then that's kind of second priority. Likely notable is third, like not notable is fourth, and then unknown is kind of the last one. So for example, if we had a malware scan that said not notable, like a malware scan that says, you know what, it's fine, but it's over here, right? And we have a path that came in as being suspicious, as likely notable, right? Then not notable wins out, right? It kind of trumps or overrules the likely notable for that, and that comes out. So this is kind of the algorithm behind the scenes. Again, we had much more complicated versions of this a couple of years ago, of numbers and this and that and multiplying and this and weights and measures and too much work. This has actually been much easier to figure out, and honestly covers most of these things. So at least give you starting points on what to look at and what to ignore. So here's some example scores that come out of Autopsy. So a hash set hit is going to be either notable or not notable. So either this is kind of either bad or good, depending on kind of what kind of hash set you say it is. Keyword hit are going to come up as likely notable, meaning suspicious, just because keyword hits have some level of false positives with them. Interesting files are also suspicious. Encryption detected is notable, but suspected is likely notable. We have these two differentiations here on how we find things, right? We know it's encrypted based on the signatures, or suspected is really more of like, hey, it's high entropy, unknown file type. It feels and smells kind of like encryption, but it could be a bootloader too. We don't really know. File extension is likely notable. YARA hit notable, and tags are either notable or likely notable, depending on what kind of tag you actually apply. So along with this, before we kind of see the UI changes, we have a new concept in here as well called data artifacts. And this is a new term that we're using to refer to extracted data, right? Meaning, for example, the web artifact, the web history artifact that we pull out of SQLite, we're now calling a data artifact, right? So historically, or even the version you all have now, because it hasn't been released yet, Autopsy makes things called Blackboard artifacts. And we were putting both things in there, both analysis results of, hey, there's a hash hit, and data artifacts like web cookies and whatever. They're now different because they store different data now, and we display them differently. So an analysis result will have a score. They're in a different part of the UI, and data artifacts have OS accounts now. It's another new feature that came into Autopsy from Cyber Triage, that now web artifacts and various things are now more tightly correlated with an OS account, so you can see all activity for a given user and separate user activity out. So not a huge difference for users, just a little bit different, as we'll see here in the UI. So those are the concepts. That's how the storage changes for most Autopsy users. That was interesting, but you'll never probably see it again. But it's just important to have kind of these conceptual changes of what's going on behind the scenes. So the new tree layout. So on the tree, on the left-hand side, in that screenshot we saw before, there are now separate sections for data artifacts and analysis results. So you can see here, there's now a data artifact section. And these are things like installed programs, recent documents, USB devices, web accounts, web cookies, et cetera. All the things that were parsing registries or parsing databases, pulling things out and saving them into data artifacts. Analysis results are all the things that we just talked about: hash set hits, interesting items, et cetera, techniques that we're applying, and they get a score. They are now in their own little section. The astute may be wondering, EXIF is not really an analysis result. And that is true. EXIF was kind of a funny character because a lot of our users use EXIF as a way to kind of focus on user content on the theory that EXIF is often stripped. So EXIF is kind of a different beast. And there's another set of infrastructure, which is not in the current version, but will probably be the next one, on keeping track of metadata overall as a separate thing, whether it's metadata from a Word doc or a PDF or pictures, and storing it there separate from this. But that we didn't get to increment that in or build that in for this. So EXIF is kind of the oddball right now out there as an analysis result, but it'll move in the future. Other place you'll see the score is now in the table. It's the screenshot we had before. As you are looking at things, you will now see this S column stands for score, C stands for comment, O stands for occurrences. This is using the central repository to see how often you've seen this file in the past. But so the scores column is the S column, and this is now going to give you a red icon if the aggregate score is notable, meaning when we figure it all out, it's a notable item. It gets red. Yellow is likely notable, etc. So there's now kind of icons on here. Those of you know Autopsy may have realized there were already icons there before, but the icons were much more hard-coded before. It is much more about like, if there's a tag, we'll put an icon on, but it wasn't doing this kind of voting system to kind of figure out kind of what the overall score of this was. It was much more just about, hey, here's, there's a comment here or tag on here, so we're going to give you this. So it's now much smarter in terms of how that gets built up. There's a new analysis result viewer. So these are the viewers on the bottom lower right-hand corner. You can see analysis results over here. That's the name of the tab. And this is going to show you the aggregate score for that item and the set of results that allowed us to get to that conclusion. So in this case, this is off of the autopsy training image where Renzik gets dog-napped. This one had 2 analysis results on it. So we can see here that there's a hash set hit on here, which gave it a score of notable. And there was a interesting file hit on here that gave a score likely notable. Again, based on our past algorithm, notable beats likely notable, and so the aggregate score here turns into notable. So so this is kind of the way you can kind of understand how an item got its actual final score. So what does this mean for autopsy module rares? So that's the kind of changes in the version coming out next week that you'll see for these analysis results and the scores. For module writers, there's one minor change. So first, why make an autopsy module? Well, the main motivation here is that we try and make it as easy as possible to make modules just for forensics, right? So here's the basic approach you use, right? You copy and paste one of our Python, Jython templates. You search around for to do and you make a couple updates. And essentially, once you make that module and you copy that template, Autopsy is going to pass all the files into you at some point, right? And that you saw that pipeline before. You will become one of those models in the pipeline, and Autopsy will pass every file to you. And you don't care if it came from a disk image, inside a zip file, that was carved or whatever. You're just going to get every file, and the kind of source it came from is irrelevant to you. You just kind of get past the file and you decide what you want to do with it, right? What is the fanciness of your module? You do your fancy stuff and you save the results to the database. We'll see how to do that in the next slide. And your results automatically show up in the UI and they show up in the report. Essentially, we do all the kind of the getting data, displaying data. All you need to focus on is really on kind of what's the fancy analytics that you want to do. So what has changed? So in the old version, right, the last version and whatever, when you found something, you would say, hey, new Blackboard artifact, and pass in some things like with a type and some data, and it would get stored as some name value pairs. Now, the only difference is you call new analysis results, and you need to pass in a score. That's it. Everything else is automatically updated. The aggregate score, UI, etc., all get updated behind the scenes. We figured all that stuff out for you. And honestly, it was a pain in the butt because we have the whole cluster set up with Autopsy and multiple clients could be updating the score at the same time and making sure this score gets overwritten, not overwritten. It's a pain, but we did it. So that's all there, but you don't need to worry about it, right? It's all done for you. You just need to kind of call new analysis results. It gets updated, put in the UI, and it gets shown to the user and works in the score. It's pretty cool. So for example, you call file new analysis result, extension mismatch. This is the type for that. You give a score likely notable, give a reason why, and you're done. So in summary, this is all in there now. We're coming out next week of basically having much more kind of infrastructure in place to actually, start bringing in this idea of scoring and ranking to kind of help users figure out the most relevant things first. So this will be out next week. The basic infrastructure was the first step. I'm a very much of an incremental person of just getting stuff out as quickly as possible and not waiting, 6-9 months to kind of make sure everything's there. So this is the first step. The infrastructure is there. The next step is to have more and more of the modules out there to start making scores so we can start to aggregate these things and get better results and focus on things faster. We're going to be expanding out more UIs to leverage this. So for example, the next release will likely have a display kind of like Cyber Triage does of, hey, what are all the bad things? What are all the suspicious things? And allow you to focus on those versus just kind of diving into data type specific kind of view. We'll also allow for overriding. Cyber Triage right now allows you to override the scores. Autopsy doesn't, but we'll get there as part of that. Again, next week, you can get all this from autopsy.com. Additional learning opportunities for those who are kind of new to DFIR or those even who aren't. OSDFCon is October 20th. As I said before, we'll be hybrid, and this is turning into a lot more work than we ever imagined it would be, but it should be a wonderful event as always, although I'm very biased, but it's a one-day event, all about open source software, forensic stuff, 35-minute talks. We're continuing to do one track as part of that. It'll be in Herndon, Virginia at our good old tried and true Westin Hotel that we've been at for many, 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 many years. So for those who are local or want to travel, we will be there. You can meet, you can mingle, but we will also have it on Zoom as well. The agenda is coming out probably next week. It's on my list of things that I'm behind on, but to kind of finalize and help figure out, but we should have that out next week. The other kind of point for those who kind of want to learn more about things, last year we launched a free 3-hour course called the Divide and Conquer DFIR process. This is basically a lot of the concepts that we built into Cyber Triage for how to kind of approach intrusion investigations. And the basic core concept of this course is you're going to start off with investigative questions, like we talked about, and the fourth slide on this. You're going to start with a question. Oftentimes that question is hard. It's a big, hard question. It may not be obvious where to go, but the process in this is basically classic divide and conquer problem solving of break that big, hard question into smaller questions and into smaller questions. And eventually you'll get down to an artifact, a type of artifact that you can look at and know where to look for that. So it's basically more of like a way of approaching investigations in kind of a methodical way of start with your question and break it down. So again, this is a free 3-hour course. If you haven't taken it, you can sign up and go through it. It's very kind of vendor agnostic. It's just kind of more of a concept there. And lastly, for those who want to learn more autopsy, there is a video-based training course. But I think since we had 100,000 people sign up for it last year when we offered it for free, I'm assuming most of you already have a coupon or a token or register for some way. But for those who haven't, there is a training for that. It's no longer free, but that's up there as a resource as well. And that is all I have.
Thank you, Brian. So I actually have a question for you. When is the call for papers, or has it closed already for OSDFCon? So the call for papers ended back in June. Okay. There was crowdsourcing. Actually, the call for papers maybe ended in May. I don't know. I forget dates. It's all irrelevant now. It's all a blur. So it's closed. We had crowdsourcing. People voted. We had a whole bunch of votes on kind of, I love this, I don't love this, whatever. And now we're going through this. And again, this is kind of the complexities of hybrid and remote of trying to figure out kind of what speakers are here, what speakers are remote. And again, it's a whole bunch of work. So we are trying to figure out all of the crowdsourced voting and things to figure out into an agenda. So. Fantastic. So I think we have a minute where I can ask you questions, and I pinned as many questions as I could to your hallway. So it'd be easy for you. Excellent. Thank you. So to be clear, version 19 comes out Monday. Is that correct? Ish. Yes. Okay. And there was ish. That's good. And then there was another question that I thought was really good. Okay. Does the hash set lookup scoring work in air-gapped environments? So in Autopsy,
the hash lookups are all local databases. So you configure your own, you import a hash set, or you make your own with our schema, which is SQLite, or in a central repository if you want to collaborate and share in your clustered lab environment. So that's all kind of, that's all offline. There's no online component to that. Cyber Triage's hash lookup for malware scanning does work in an offline environment, air-gapped environment. You can export all of the hash values into a text file. Maybe it's JSON. I think it's text. It is plain text. No, it's JSON. It's a JSON file. You export out. You can review that if you want to. Bring it over the air gap. Upload it into a website that we have. It gets you the results. You import it back in again, and it makes scores and things, on there for you. So,
fantastic.
Air gap is supported. Yep.
Thank you, Brian. This was fantastic. And there's still time to vote. There's still time to vote for Autopsy. You were up for Open Source Tool of the Year, right?
That's right. Yes.
Okay. Still time to vote. Perfect timing, Brian. Perfect timing.
Well done. Thank you.
Thank you.